All right, hey guys, JMO here. We're doing part 13. This one's called hubcap because clearly it looks like a little hubcap. The reason we're doing this one is because I touched on it earlier in one of the other videos, and I wanted to expand on it because, you know, if you're going to touch on something, you might as well finish it. So what we have here is a few different views. We're doing it a little bit differently in this one, mainly because you need some different views, and we can show you a different view here. We've talked about section views before, but this one is actually going to be utilized, I believe. I don't think we really utilized the other ones. So let's go just like left from right. We've got our material, aluminum. We've got, why is that spelling look wrong? If it's not, it's whatever. If it is, my eyes aren't seeing it. 55, 30, 8, 8, and we're seeing this times C. So this can be a variable amount of holes, which makes sense because not all cars have the same amount of nuts that go in to keep the tire on. So think about that kind of stuff. We could change that. Then we have like the length of it and the width of it, or however you want to see it in your mind. That kind of variable changes can make it bigger, wider, fit multiple parts, be changed on the fly, and that's why they like to do things like this. We have these angles in here. It's one's for the bottom or the bottom one or the top one, however you want to see it. So make sure to look at where these lines are coming off of. We have a little center circle, which is a 20 radius, which shows the concentricity of these circles. And then we have the thickness shown here as well as here and here. And that kind of tells me that this is going to be a shelled part. You can kind of tell it's been shelled out 10 to 10. So it's an easy way to look at that. And these are the holes because this is a sliced view. Imagine again, someone took this, cut this directly in half, pulled one of these parts, I believe it's this part because those are the arrows, and then turned it 90 degrees to show you the cutout. So that's section BB. That's how you do it. You'd go into drawings, section view, make it horizontal or vertical, cut something, and you can keep cutting it. It's a pretty cool little feature. To talk about something too, the top, you see how that moves in relation to that part? I did bring this piece in separate from these. Normally this would not be able to move without this. So this would all kind of move together. But I brought this part in and then made it relate to this. And then I brought this and made it relate. So we could go kind of like that left to right showing. But know that it wouldn't normally lock like that. Okay, I think we've covered everything we need in the drawing. Let's jump over to the part. We're going to go a little bit faster like I've been talking about because, we're getting better. One thing I do want to touch on, actually, I kind of jumped away a little too soon. You might think, and I think I touched on another video, so sorry to keep saying that, you could circle on a front view, extrude out 10, draft to 30. You don't know the distance, though, so it'd be kind of hard. You could guess it by putting the parts together later on, but I think it's better to draw this half view. Like imagine we cut it in half again here. Draw that view, shell it, and then make our circle cut. And this is the first time you're going to see the shell tool and the linear pattern, or the circular pattern tool. All right, let's bust it out. Right plane. We had this. I skipped a step. I'm skipping 2 steps. Sorry. Boom. Quick fix. Equations. A equals 55. B equals 30. Not 3. C equal to 8. Awesome. Sorry, still fighting that cold. A little stiffly. Sketch. Right plane. This was equal to A. It's vertical. And we had like a little line off here. I think it was 10, honestly, if my memory's serving me. I think we don't know the distance of this one. We do know the distance of this one across, but I'm not going to put it in. And then it comes down, and it relates. We knew this is equal to B. We knew, this is 5. And then I think we knew this whole thing. No, we already knew the whole thing was 30. What am I missing? Oh, the angles. Yeah, still let me forget my angles. That's how we do that. This line to a straight line near it, 30. And then even though it's farther and not attached to it, we can still go to this line, 60. And you can see that puts the distance in for this line because it kind of like completes the triangles that create that geometry. Okay, features, revolve this thing, and we're going to revolve it around that bottom line, of course, to get our isometrically correct view. Now, first use of the shell tool. Cool. Let's hit this. The shell tool likes you to pick a face, and then it basically shells into the item into the direction of that face. So you could do like a multi-thickness and step off from another plane or another face. But I don't use it too often. I think I've used it once. It's cool. We got that shell, and it looks pretty good. Let's now put our circular pattern hole in here. We're going to sketch on that front face because it works easy. We know it was an 8 pattern hole. Let's start with one circle at 20. No, that's too big. I think it was 10. That seems right. We knew the reference circle was a 20 radius, so we can put that in because that'll be our distance reference. Let's now make this vertical. All right. And then we can make our hole cut. And I think we've talked about this a little bit before. Some people like to do pattern cuts in feature. Some people like to do them in sketch. So you could do that sketch pattern, linear pattern, the circle. But I've heard people like to do it this way. So I mean, I don't have a preference. I'll do it the way I've heard people like. So you guys kind of see it that way. If you guys like it the other way, you can do it the other way. So now we're going to do a feature linear pattern, or circular pattern, excuse me, I think I've done that twice now, of that cut. So it knows we want this circle because it's doing that cut extrude as the feature, but it wants like a circle reference for concentricity, if I'm saying that right. I think I am. Boom. All right, we have our 8 cuts, and I actually did that wrong too because it automatically filled in 8 for me, which was lucky, but we could do this equal to C. Let's not forget that, which is the same thing. But now let's say we need to change C. Now our cuts magically change, right? So that's something we need to be thinking about. And of course, with any of those equations, we've done this before a few times. We can change any of these. Let's double it in size almost. And that really does change a lot of the part, right? If the tire was really big, but the axle was the same, and where the hubcap would pop onto or fit, you wouldn't want these to change, but the tire could get bigger, right? All right. Oh, that didn't just take the size down. That's cool. That Control Z, not cool. It's actually kind of weird. That Control Z took 2 things away, or maybe it just did it twice on me. Interesting. Ignore that. We've got our part. We need to put it in aluminum. It was spelled right earlier. Huh. Cool. I'm glad. Oh. Alumina. I thought we could pick aluminum here. I wonder if my materials have gotten janky at some point. I might need to look into this because I could have sworn you could just get AL in here, but maybe you can only do... Huh. Yeah, sometimes my brain fails me, guys. I'm not always on it. That's okay, though. We'll continue learning and teaching together. But anyways, we're going to use 1660 alloy aluminum. I like that. It feels good. Looks right. Might even be what they use in the real world. I don't know. I could do some research, put that in the comments or the description if you guys want. But that's a basic hubcap with a few different tools and things that we haven't seen before. So add them to your belt. The shell tool, right? Revolving around a side sketch. Think of those thin slices that you might need to draw. And then think about the axis of rotation that you might need to utilize. The circular pattern tool, again, we use that as a feature, not as a sketch. You could use it within the sketch. It is a sketch option. And then, yeah, the only difference would be, again, you'd have the sketch be the circular pattern, and then you just extrude it, and then this would be gone. So I don't always know why people like things specifically like that, but that is why they like it. So that's what we did it. Best practices, let's cover that. Go ahead and pause the video at the start. Try to draw it yourself. It might be a little tough. You might make that mistake unless you watch all the videos and you're picking up on all the little things. What we are going to do as well, and to continue these best practices, in the description below materials, check for that change because we're going to continue changing these one time. I'll maybe change the number of holes and the size of, we'll change A and B, or A and C, and then we'll update that mass properties. So we'll have 2 of those in there. You guys go check the first one, make the updates, check the second one, confirm you did it right. I think that's all we have for this one. Appreciate it, guys. Thanks.